Okay, so chapter 2 starts to talk about derivatives, and this is the part that I told you is pretty much all of the rest of first semester is derivatives. So the beginning of it is just explaining that a tangent line is a line that hits a curve at only one point. So I believe you know that, but just kind of for a visual, if I have this curve, a tangent line would be going like this. At one point. A secant line is a line that hits a curve at 2 points. So I've got maybe this point, and it's going across that way. To get a line for any, or to get an equation for any line, there's a couple of things you could have, but we're going to focus on what happens if you have a slope and a point. You could have 2 points, and then you could find the slope that way. But we're going to focus on this. You could also have slope and a y-intercept, but that is still a point, so I'm considering that the same thing. Okay, so the definition, the limit definition of a derivative is this, and this seems very confusing. A lot of the time you'll see an x right here instead of a c. So then that, honestly, for me, it makes it a little less confusing. I just feel like I understand that a little bit better. But I'll start with this. In this first problem, they want me to use that definition, and basically it's just the slope definition. That's really all it is. So h ends up being your change in x, and then the function at c plus h minus the function at c, that's your change in y. All right, so let's start with this one. To use this definition, so this terminology right here is the slope of the tangent line. So m tan equals the limit as h approaches 0 of the function at c plus h. So instead of putting x here in the function, I'm going to put c plus h. So this would be negative 5 times c plus h plus 1. That's that function at c plus h. Minus the function at c. So instead of an x, I'm going to put a c right here. So negative 5 times c plus 1. And I'm going to put this in parentheses. That's really important because of this minus sign right here. And then that's all over h. So then let's simplify that a little bit. So I still have the limit because I'm not plugging anything in yet. If I were to plug 0 in, I would get 0 in the denominator. So I really have to simplify some stuff. So let's distribute this. This would give me negative 5c minus 5h plus 1 is just kind of on its own here. And then this negative distributes, and that becomes plus 5c and minus 1 all over h. So what you'll notice is things cancel out. A lot of things cancel. So a negative 5c plus a 5c, those cancel. And a 1 minus a 1, those cancel. So I end up really with the limit as h approaches 0 of negative 5h over h. Well, then if you look at it, those h's simplify. So really, I end up with negative 5, and I don't have to use my h approaching 0 anymore because I just get negative 5. So that's my answer. Now I want you to think about this for a minute. So let's go back to our original function. This function is a linear function. In this line, my slope is negative 5, my y-intercept is 1. So the slope of the tangent line, no matter where I attach it, so I've got this negative 5x plus 1, so it's got a negative slope like this. No matter where I put my point, my tangent line is still right on that line, which matches up with the slope of the line. So it makes sense that negative 5 is the slope of this tangent line. Okay, this one's a little bit different. This one is an x squared, so this is a quadratic function. I'm going to do the same thing though. Now they gave me a couple of points to look at, but I'm not going to do that yet. I'm going to stick with this method for right now. So the slope of the tangent line equals the limit as h approaches 0 of, I'm going to plug in c plus h right here. So c plus h squared minus 2. All of that minus c plugged in. So c squared minus 2 all over h. And then I'm going to simplify. Now this c plus h squared, that shows up quite a bit actually. So I'm going to, up here, I'm going to show what happens when I square this out. This would be c squared. That'd be plus ch plus ch. So that's really plus 2ch plus h squared. So that's this first part. C squared plus 2ch plus h squared. And then I've got a minus 2 on there. Then I'm going to distribute my minus sign. Oh, I forgot my limit notation. Limit as h approaches 0. Okay, so then let's simplify. So this first part, a c squared minus a c squared cancels. And a minus 2 plus a 2 cancels. So I end up with the limit as h approaches 0 of 2ch plus h squared all over h. And again, I've got some h's that will cancel. So as long as every term in here has an h, I can cancel one out. So now I only have one right here. So this is the limit as h approaches 0 of 2c plus h. Well, really what that means, if I plug in my 0 right here, that's 2c plus 0 or just 2c. So my limit definition is this. Now they want me to find it at exactly these 2 points. Well, like I said earlier, c can really be substituted in for x. X could be substituted in for c. So 2c, so at the point -3, 7, 2 times -3 is my slope, which is -6. At the point 1, -1, 2 times 1 would be 2. So these are my 2 slopes for that problem. Okay, I'll finish the rest in the next video.